In this video, I'm going to show you how to solve for kinetic and potential energy. So in problem 1, Roger Maris swung a bat, which has a mass of 2 kilograms, at a velocity of 45 meters per second. How many joules of kinetic energy could he give to a ball? So the first thing that I'm going to do is write down all my knowns that are given in the problem. So the mass is 2 kilograms. Okay, it has a velocity of 45 meters per second. And how many joules of kinetic energy? So I'm solving for kinetic energy. That's my unknown, and it's measured in joules. So the next thing I'm going to do is visit my equation sheet. I'm going to write down the equation for kinetic energy. Ke equals 1/2 mv squared. Okay, then I am going to plug in everything that I know. I'm just going to write down 1/2 is 0.5. It's a little easier to plug into the calculator. My mass is 2, and my velocity is 45 squared. So the only value that is squared is the 45. Then I'm going to put everything into my calculator. And my answer is 2,025 joules. Okay, so that is if I'm solving for kinetic energy and I'm given my mass, my velocity, I can plug in everything and get an answer. Okay, problem 2 that I'm going to show you is a little different. They give me a couple different values for kinetic energy. So an object is moving now. It has a velocity of 67 meters per second. And now they give me the kinetic energy. It's 500 joules. And it's looking for me to find the mass of the object. So this time mass is my unknown. So what I'm going to do is I'm going to do the same thing. I'm going to write down my equation for kinetic energy. I'm going to write down 1/2 is 0.5. It's just easier to plug into the calculator that way. I'm going to plug in my kinetic energy is 500 joules, 0.5. My mass is my unknown, so I'm going to keep that as a variable. I'm going to drop my variable down. My velocity is 67 squared. So all I did was substitute the values that were given in the problem in for the variables in my equation. So now the first thing that I'm going to do is I'm just going to simplify this. 67 squared, I can plug that into my calculator, is 4489. I still have my variable, so I'm dropping that down, and I still have the 0.5. And that equals 500. Okay. Then what I'm going to do is I'm going to simplify the 0.5 and the 4489. They are both being multiplied by m, so I can simplify those together. So 0.5 times 4489. So all I did was multiply these. I get 2244.5 m equals 500. Okay, then the 2244.5 m is being multiplied. So I'm going to divide by both sides. Those cancel. Whoop. And I'm left with m is equal to 500 divided by 2244.5. 0.22 kilograms. Okay. My last example that I want to do is solving for velocity. So I'm going to do one more example, and this time I'm going to solve for velocity. So an object has a kinetic energy of 25 joules. Okay, its mass is 34 kilograms. How fast is it moving? So this time I want to solve for velocity. Okay, I'm going to do the same thing. I'm going to write out my equation, KE equals 0.5 mv squared. I'm going to plug in everything I know. Kinetic energy is 25 joules. My mass is 34 kilograms, and this time I don't know V. V is squared. I'm going to keep the squared with the V. I cannot square anything because it's with V, the variable. So the first thing that I'm going to do is simplify 0.5 times 34, which gives me 17 V squared. Okay. Then the 17 is being multiplied by V squared. So I'm going to divide both sides by 17. Then I'm going to take 25 divided by 17, gives me 1.47. Okay, and then my last step is to square root both sides to get rid of that square. So V is equal to the square root of 1.47, which is 1.21 meters per second. So those are the three examples of how to solve for kinetic energy, depending on which variables it gives you.